So in continuation with the previous class, in continuation with the previous one, uh, so here again we'll have a discussion on the basic structure and operation on the power transistor. So power transistor, the word itself says very clearly about power. So I told you in the introductory part, whenever we go for any driving power modules or power devices, or in terms of an electrical power, or in terms of operating an electronic device, the help of electric power to drive a huge amount of application, then we should know about what exactly we are trying to speak about power, either in terms of a voltage terminology or in terms of a current phenomena. Please remember in your mind. So in general, power we are trying to speak about in terms of V into I. Okay, in terms of watts we are trying to speak about that. Okay. So here transistor terminology will have four types. One may be BJT. You all know about that. I think the things which I am discussing right now, I told you earlier, known by you people, because we are just integrating two things. I told you very clearly. If you understand that terminology, then you may feel that the subject is quite comfortable and you may feel that very easiest subject for this semester. Because switches, you had a separate learning in solid state switches. All the switches in a brief manner and along with the characteristics, the basic expressions, equations, all those things you learned it in a separately. And again, you learned separately for electric drives and actuators. There you learned about the various machineries and the functions, the voltage, current, torque, and speed characteristics of your DC motor, generator, then induction motor, and your the other special machines you might be learned in your uh, earlier classes. So now here the duty is to, whenever you go for any high power module application, you wanted to know about that, how we are trying to integrate. So here the main objective behind learning of power electronics is to integrate your switches as well as your machineries or your drives and actuators. Please remember, if you set that objective in your mind, then remaining things are very easy to, because both the subjects you learned separately on the previous year. Now we may have an integrating part only. Please remember in your mind. That's why I told you, when this semester comparing to the other subjects, this subject you may feel quite comfortable and easy to you, and many things are known to you. That's what I just wanted to stress to you people. And bipolar junction transistor BJT, then the other switch is metal oxide semiconductor field effect transistor, or we may call it as MOSFET, and the another one IGBT, integrated gate bipolar transistor IGBT. But normally, when we go for a practical implementation, we don't prefer much on IGBT. Rather than we may go ahead with the MOSFET and the thyristor. The last class we discussed about ACR or thyristor, right? Silicon control rectifier. That switches we may consider. Please remember me, mind. Most of the practical application, even when you go for your development of your project or a minor project or major project, or to the help of a suitable DC motor to drive your robotic certain part, then you may consider about your ACR or a thyristor, commercialized thyristor, we used to consider about that. Please remember in your mind. You may ask a question right now. Though there are n number of switches are available, how do I select? Please remember in your mind, when you select a particular switch, in order to go for a suitable application or in order to go for a suitable drive, please remember in your mind, we should consider two things. One, we should consider about the cost. Second one, we should consider about the switching losses. Suppose if I keep on adding more amount of switches on a bridge network, definitely my circuit will have more amount of losses. When I keep on adding more, either in terms of a single phase or a three phase, if I keep on adding more amount of switches in the sense I am speaking about all these various switches I am saying, in a generic way I am saying. So please remember in your mind, Switches, if I keep on adding, then I will have more losses. Always, whenever we go for any fabrication or any device modeling on any or we apply any methodology, please remember in your mind, we wanted to have a concrete output, right? We wanted to have a concrete output. We wanted to have a solid result or a target. We just wanted to attain with a good amount of result. Then in that case, then we should avoid about all the losses. When I increase the amount of switches, then I will have more amount of losses. So please try to pay much attention when you go for using the suitable switch. Then you should avoid increasing more amount of switches. So try to reduce as much amount of switches. That's a constraint. Please set it in your mind. IGBTs, your insulated or integrated gate bipolar transistor. The another one, static induction transistor, the old version, and maybe in the commercialized in the old industries they may be used, but some in the induction application in the sense you all know about Faraday's law of electromagnetic induction. And just a minute, let me check my connectivity. I think it's okay. Can you able to hear my voice? Those are online. Can
Yes,
you
sir.
able to?
Yes,
Yes.
sir.
Yes,
It's audible, sir.
Okay. Because I'm getting another voice on my headset. That's why I just asked. Okay, fine. So induction transistors. Okay, when we go for induction operation or induction principles, like with the help of Faraday's law on electromagnetic induction, there are many n number of induction principles and appliances are now available. So basic terminology. Okay, we can go ahead with the static induction transistors and other things. Please remember. So power BJT again, the structural wise we speak about three layer, two junction, NPN or PNP. So that's why we started with the transistors on NPN and PNP type. Bipolar means we are trying to speak about current flow in the device is due to the moment of either holes and electrons. We all aware about that. From 12th onwards, we are keep on learning about the fundamental on physics, right? By learning about NPN and PNP terminologies. So here the moment of both holes and electrons. So this is the schematic representation of your power BJT, and C indicates collector and B indicates base and E indicates emitter. Okay, so maybe the same story gets repeated again and again. You may have fed up with many things, but still, it's a recollection on my point of view. At least I just wanted to recollect some glimpse of amount of things which you known earlier, but still, as a concrete learning, at least we should have a brush up of all those things. Please remember. And this is the term structural representation on your NPN and PNP in terms of base current, emitter current, and the collector current. Okay. So this is the VI characteristics of a power BJT. One may be the first circuit represents about your NPN transistor, and second one speaks about the input characteristics, and third one speaks about the output characteristics. So input characteristics, okay, here your x-axis, the relationship between your base emitter voltage and your base current. Suppose if I go for the output characteristics, I should go ahead with the collector emitter voltage and the collector current. Okay. So please remember in your mind, all these characteristics will give a clear understanding on the device selection. Suppose when I going to drive a particular machine, for example, either a DC motor or a DC generator, or for example, I can say that a single phase induction motor. When I wanted to drive the drives for a suitable application in the sense for lift or conveyors or elevators or all these applications, when I go for, or if I can say that when I go for a power utility or a power grid, okay, micro grid or power grid, when I wanted to go for a suitable application, based on the characteristic curve, will tell you about what sort of values which I am able to use or which sort of rating I should go ahead with the switches. Either if I go ahead with a BJT or MOSFET or TRIAC or DIAC. In the earlier classes we discussed about TRIAC and other things, right? So there are a number of switches are available. So please remember in your mind, this type of characteristics will clearly will give you about the relationship between the two terminologies, either from the input aspect or from the output aspect on a particular switches. Provided selection on the switches only will tell you about the portfolio and the fulfillment on my output aspect on the application point of view. Please remember. That's why please remember, whenever you go for any drivers or any drivers, I'm not see. Please don't understand it in a different way. There are various drivers. Even you all know about your software drivers, hardware drivers, electronic drivers. I'm here speaking about the electrical drivers. Please remember in your mind. Here all I'm speaking in terms of the electrical terminologies. Okay, so please remember, because here we are trying to our electronics trying to deal with the electrical drivers. Got my point? So please don't confuse that. There are various amount of drivers are required. You all know about that, why we need drivers in order to have a smooth functioning and in order to have a smooth output or in order to have a an expected targeted output. So here power BJT, the input side I'm considering the characteristics between my base current and my base emitter voltage, and the output side I'll be focusing on my collector emitter voltage and the collector current. Okay, what are the switching characteristics of BJT? Now, please, if you see this diagram, here I'm representing a BJT diagram with the NPN transistor with resistive load. Okay, here we are normally what are all the loads we consider when we go for an application point of view? Either we go ahead with a resistive load or inductive load or a capacitive load. You are aware about that. So that means, please remember in your mind, normally we check with the help of a resistive load. Sometimes depends on the application. If the load utility is more, if the application perspective point of my load is more, then here I'm talking about load in the sense I'm speaking about in the output side. That means, please remember, depends on my load only, then I will decide about my the input values and other things. Please remember in your mind. So here this circuit appears to be like an NPN transistor, or you just recollect some things which you learned 1 year back. This type of circuits are sometimes acting as an amplifier. Please remember. So therefore, a kind of signals will have an amplification is required. Here your BJT or this one will act as an amplifier. Okay, this type of circuits, in order to, there are various classes of amplifier. Class A amplifier, class B, class C, or class AB combination, BC combination, and you might be learned in maybe just 1 year back in your solid state switches. So we don't want to categorize into class A, B, and other things. I just tell you about. So here this type of circuits may act, BJT may act as an amplifier circuit. So here depends, the load selection depends on my output utility, which application I'm going to focus based on that the load. So here for a trial and error, we may connect with resistive load or inductive load or capacitive load. Sometimes resistive, inductive, capacitive combination. Maybe I think the same thing you might be executed in the laboratory. You might be used to some lamp load and other things in the electrical labs. I do not know exactly whether you attend. I think you attended online. Okay, maybe you did not get an opportunity to visit the lab. Sometimes we may have a lamp load to connect the output side to check the characteristics or the performance. Okay, so please remember, always in electrical terminologies, we should know about we have input. Then in the processor side, we may have a system. That system may represent by my electrical unit or my electronic unit. When I speak about my electrical or electronic unit, here I'm trying to speak about my switches with a combination on my drivers. I have my own switches, various amount of switches I have. With the help of switches, I'm trying to drive or I'm trying to control my output side with the help of a suitable voltage or in terms of a current. So here I have a transistor with a resistive load. That means I can be able to find out three things here. One, I can able to check my collector current characteristics. Then I can able to check about my base emitter voltage, how much quantum of base emitter voltage I am acquiring here, and also I should find out my value on collector emitter voltage. So these are all the three values, or even I can able to find out what is the emitter current I'm trying to draw here. Okay. So That means, please remember in your mind, VCC is the main supply voltage I am trying to give, and resistance will act as resistance will have an ability to restrict the amount of flow of current from the collector perspective or the collector current. That means, please remember in your mind. So this amount of circuit will act as an amplifier in order to amplify. Suppose if I have a low quality signal, so when I wanted to amplify this type of BJT circuit will act as an amplifier, and thereby it will have an ability to increase the amplitude of my signal. Are you trying to understand? See, always if my amplitude is good, my quality of the signal is good. If my because any signal, if I speak, my amplitude and my time period are interlinked. For a complete half cycle, you all know about that. For a complete half cycle, positive half and negative half together, I have a complete cycle. Yes, 0 to for a 180 degree, from 180 degree to okay through 360. All together, I am considering here as a complete half cycle. Okay, in a half cycle, two things are important: frequency and time period. When we deal all these electronic devices with the interfacing on my electrical drives, then signals plays a vital role, or signal conditioning plays a vital role. That means either two things. One thing, we may be able to acquire the signal, or second one, we may be able to trigger the signal. For example, certain switches, you may have a gate terminal, right? You may have an anode terminal, cathode terminal, and you have a gate. That means when I wanted to turn on my device, I should give a kind of triggering or an instant amount of signal onto my gate. Thereby, I can make the device to be able to understand. Though I may able to give the supply or other things, certain devices or certain, for example, triode or track and SCRs, I just wanted to give a triggering instant of signal to my gate terminal. Please never forget about that. A kind of triggering, a kind of instant signal I am trying to give. Thereby, the device we are converting to be on. Got it? So here, the switching characteristics for BJT, we consider about the base emitter voltage characteristics and the collector emitter voltage characteristics. So this is the switching characteristics of my power BJT. So here, maybe diagrams need not be looks like much visible. Maybe if you zoom it, okay, at least you can able to uh, if you just be check just a minute. If I zoom, okay. Now I think it quite okay. 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 Now I think it's quite okay. Okay. So here every instant of my triggering on my positive half and my negative half cycle, my waveforms will have an ability to either in one two things may be improved. One may be to improve my amplitude, and another one may be the time period. So whenever I'm trying to improve the amplitude, please remember in your mind that amplitude will speak about the quality of a signal. Got my point? So this is the switching characteristics of your power BJT. Now we just wanted to know, when I told you about the turn on. The two things I told you. Either I should be able to turn on my device or turn off my device. Okay. See, normally the other devices, okay, for home appliances, when we speak about that, we may speak about two things. One may be on and another one may be off. Okay, the two things. That also we are using all switches only. Okay, one may be in the on position or another one may be in off position. That we may call it as an on-off relay, or otherwise we may call it as an on-off relay. The other relays are available: inductive relay, capacitive relay, electro-inductive relays. Uh, these relays need a kind of instant amount of triggering or a pulses required. So that only we are trying to speak it on the switches. Certain amount of switches are required, a kind of triggering or a kind of instant pulses to make the device to be on. So here, I think in the system dynamics, you might be learned about when two stages of your system. One may be the steady state, and another one may be in the transient state of your system. Maybe you just 6 months back, you might be not 6 months back, yeah, 6 to 8 months back, you learned about system dynamics. There are two things maybe you learned. One may be steady state, and another one may be the transient state of your system. During both the stages of your system, your system consists about time parameters. Whenever we speak about frequency response, we also should focus about the time response. And that means delay time, rise time, peak time, settling time, overshoot. These all parameters have amicable amount of concentration when you go for a complete set of process. That means when you wanted to analyze a frequency complete response or a time related analysis, please remember in your mind these the time parameters we have to consider. So here turn on time of the power BJT may be considered here as the delay time and rise time. So maybe I think you have learned earlier delay time, rise time, peak overshoot, and finally you may be learned about settling time. So where exactly it rises and where exactly it's trying to fall, then at some instant again it will maintain the same value, and one instant you will have the settling time. So here delay time or TD is the one. During this time your base emitter voltage may be applied, so that what will happen when you apply your base emitter voltage and automatically your base current rises. Therefore both the values, it may reaches up to the collector current, it may equal to 0. That means the collector current rises from 0 to just a 0.1 second, or your collector emitter voltage falls from 0.9 voltage. That means the maximum slab we may consider 1. From 1 to the reduction on what value? Just a 0.1 value reduction. That means 0.9 volt VCC. That delay may be considered here as the delay time. So obviously, on a common aspect, we may consider about the base emitter voltage may be taken as 0.7 voltage, or 0.72 we may consider up to 0.9. Maybe these things, if you have done it in the laboratory, maybe in the last semester on your solid state electronics, you would have understand little more better. So second one, rise time or the TR indicates rise time, TD is the delay time. So this time maybe it may rises from 0.1 second to 0.9. Earlier one delay time from we may have a fall, or we may have from collector current rise from 0 to 0.1. At the same time your collector emitter voltage falls from 1 volt to 0.9 VCC voltage. So here just a reverse, I see a collector current rises from 0.1 to 0.9. Therefore collector emitter voltage falls from 0.9 voltage to 0.1 voltage, a sudden amount of fall. And during this delay time or rise time, the transistor remains in on state for a long period, so that for the forward base current is maintained. So two terminologies when you turn on process of power BJT, one is delay time and another one may be rise time. But remember, here we don't here many of the things are in terms of seconds or milliseconds or even in nanoseconds, not like an hour basis. Okay, because these are all electronic components. Also switches I'm speaking about here are all electronic switches. Okay, maybe we may speak about many processes may take hours together, right? If you go to any automation industries or other industries, many hardware drive will take hours together. But here all instant of triggering or instant of pulses we are trying to give, all instant of time duration maybe like 0.1 second or sometimes 0.01 second, something like that. It's a minimal amount of instantaneous changes happen. Please, that's why we call it as instantaneous changes on the voltage and the current. In electrical and electronic, people may use about the instantaneous amount of value or the root mean RMS values. So please remember in your mind, we don't have changes occurs like more amount of hours and other things. Here we all changes happen from a 0.1 variation or a minimal amount of milliseconds or seconds, or even we can speak about nanoseconds. Turn off time of your power BJT may be the storage time or the fall time, or the amount of fall from 0.9 to 0.1. That means storage time. During the time the collector current falls from 0.9 to again your 0.1. That means the voltage collector emitter voltage will have a rise to 0.1 value. And fall time during this time the collector current falls from 0.9 to 0.1 seconds. So these all things may be happened on a single instant of values or a very minimal amount of time. Please remember. Now, when we discuss about the characteristics, one important aspect is called SOA or safe operating area. Safe operating area for not only power BJT, every device we used to speak about the safe operating area. At a particular region where the device is triggered and thereby the device may have a correct operating condition that limits the collector current as well as your collector emitter voltage on your BJT. For reliable operation on your BJT, collector current and the collector emitter voltage must always lie within this area. That means the characteristics values which lie between the range of safe operating area. There are two types of safe operating areas. One may be FB-SOA, that means forward bias. FB indicates what? Forward bias, and another one indicates reverse bias. Because normally here these are the two types of biasing happen. One is forward bias and another one is reverse bias. FB-SOA and RB-SOA. Don't confuse them. Okay, so this is the characteristic curve on the safe operating area region. And when we speak about the safe operating region, please remember in your mind, in your x-axis, we are trying to speak about the collector emitter voltage, and the y-axis, we are trying to speak about the collector current. Okay, one in terms of voltage, and another one, the characteristic curve. Second one, you have a drastic fall on the base current. Three things of three set of curves on a single point in the right side diagram. So one is in IB is in 5 amps, second one 2 amps, the third one is drastically reduced to 0. But the same thing in the other side, if you check about the drastic fall on from my transient state to the fall value from A to B, I have a constant value. From B to C, a minimal amount of change. Again, from C to D, I have a drastic amount of reduction on. That means every stage of my reduction, when I check the time parameter, for example, I told you about the time duration in terms of seconds or in terms of milliseconds and microseconds. We don't speak about more amount of time because every minimal amount of time duration, my values will have a drastic fall. So that means, so forward bias to safe operating area, we consider about the value is less than 25 degrees Celsius. And here, please remember in your mind, the second one, reverse block safe operating area or RB SOA. Please remember in your mind, only three values actually we have considered here. But remember, we may have some more values, like for example, 5 amps or 4 ampere, 3 ampere, what is the curve? These all curves might be very closer to here. That means at one instant, at the value of my collector emitter voltage, when the value is nearby 250, automatically I have a drastic fall on my base current. That means my collector current will have a drastic fall. Thereby, I can able to maintain my base current as 0, 2, and 5. Second one, okay, earlier one we discussed about BJT. Next one is MOSFET, metal oxide semiconductor field effect transistor. So we have the three terminals. You all know about that. The right side diagrams looks like your commercial. If you go to a shop, or if you go to when you are going to do your project, when you go to electronic shop and get a MOSFET, maybe the components looks like to be like this. Okay, the left side you have a schematic representation, drain, source, and gate. You all know about that. These are all the three terminals you will have. Okay, earlier cases you have base, emitter, and collector. So here you have a gate to terminal. D indicates drain and AC indicates the source value. Okay. Power MOSFET, three terminals, drain, source, and gate. Then it's one of the voltage control device. And the gate circuit impedance may be high. That means gate current can be driven directly from the microelectronic circuit. So many microelectronic appliances, we may go ahead with the power MOSFET used in low power high frequency converter or SMPS and inverter. I think you all aware about the SMPS, switch mode power supply. Maybe I don't know in your generation whether you are aware of it or not. Some of you might be having your desktop system, maybe the old version before getting a laptop or a twin top or palm top, whatever maybe. The earlier, I think many of you might be, maybe in your school days, you might be used about desktop systems with CPU and other things. If you open the cabinet of your CPU and if you see that, you may have your own SMP separate unit. Switch mode power supply. It's a separate supply which is given for your CPU in order to drive all the internal architectures or internal components which is associated inside your CPU. So there we are trying to use your MOSFET devices. Please remember. That's why I told you these all switches will have n number of applications. Okay, and one more important thing, I can use here. They may say that power MOSFET may be applicable in SMPS. Not only power MOSFET, even I can consider my the earlier one power BJT, and I can design a device in such a way that that may act as a supply on my uh, even my desktop system or the other systems. That means, remember in your mind, uh, you may able to give a power supply from your main module. The electrical power supply 50 hertz 230 volt supply you are trying to give for a main board. Then you may have lot of drivers, lot of internal architectures in your central processing unit as well as your monitor unit as well as your keyboard. Now all together, these all together, you may call it as a laptop or very compact in nature. Okay, these all things are now tiny integrated components are designed in such a way that now everything are amicable in nature or compact in nature. Okay, but remember in your mind, if you open this structure and if you just open the cabinet and if you see the internal architecture for all these processes, please remember in your mind, you may require many amount of power devices, because 230 volt power supply we cannot directly give it to here. That value will be either with a suitable transformer. I may reduce the voltage to 5 volt or 12 volt, and then I may start using the device operation. Please remember, because we never look into all those things. We may know that okay, I have a system, I have a power module, I am just using, but we do not know exactly knows about that. What are all the internal architectures and how the internal architectures are working, and what are all the internal specifications I may. Sometimes I may have various power module on a single unit. For example, in one module I may require 5 volt, and another module I may require 9 volt, and another device, for example, I need a for microcontroller I may require for a 9 volt or some other supply, some external supply I may require. I think now parallelly you are learning microcontrollers, right? Microcontrollers or embedded system, I think you are learning. Okay, you all know about the microcontroller code. Microcontroller also will act as a processor, right? Yes or no? A microcontroller or microprocessor or your embedded system, these are all acting as a power processor unit. Okay. So various device modules may require their own power requirement. That's why these switches are suitably used for that particular area in order to drive many operations together on a single board. Please try to understand. More amount of appliances are integrated together, and more amount of operations are integrated together, and thereby you are trying to drive a particular unit. We are saying that in general we may call it as a system or driver or driving unit or whatever may be. Please remember in your mind. But when you see the internal architectures, you may have various amount of separation. Please remember. So switch modes of power supply, okay. Even in your houses, I think you all know about that. You are all using stabilizers. Yes or no? You all heard about that, okay. And some of the houses you may be using inverters. Maybe I think some of the TVs, some of the fridge, and even some of your air conditioner, you are using the step up and step down devices, right? So these all things. That's why I just wanted to tell you, every device now you wanted to have your own device. For example, here, okay, we have considered about SMPS and inverters. I think many of you come across with many household modules, right? Even a stabilizer, in order to stabilize the voltage, to give the required adequate amount of voltage to drive your fridge for running. So that's why in the houses you may be used to your stabilizer, because normal EB supply may vary. 230 volt, we are saying that 230 volt, 50 hertz. Okay, 50 hertz frequency they may be maintained, but do you know that will they maintain the power factor? Power factor normally to be maintained in India 0.9. Okay, if you go to abroad, They are, for example, if you go for studies or job, you may use the device in terms of 60 hertz. In Canada and the US, you may be used about 60 hertz. But in India, we are constantly maintaining about 50 hertz. That means, okay, yeah, on a contrary, okay, we may have a standardized set of power rating, but at the same time, when we go for dealing with all these electronic devices, please remember in your mind, every single processor wanted to have a separate power module. Please remember that power module may the voltage may even for your mobile phone you may have a charger. The charger rating may be there 5 volt or something. I hope many of you are aware about that. And you may have a laptop, you may have a separate charger, and you may have the other devices, electronic gadgets, other electronic devices. You may have your own separate charger module with some power rating is there. Will you agree or not? That means please remember in your mind there are these all the switches are separately. We try to speak about that a separate electronic module, and these all the devices when we are going to apply in a overall processor. That means every power module device may have their own voltage requirement. Something requirement. Sometimes it may require 12 volt. Sometimes it may require 9 volt. Sometimes it may require 5 volt, and so on. Please remember me. That's why this converter inverter circuits wherever we are using, whenever we are trying to speak about AC to DC conversion or DC to conversion with the help of these switches or with the help of this power electronics devices, then please remember in your mind we are trying to use about various power module on the requirement part. Please remember in your mind. We don't use a single power module for driving this entire device. Please don't confuse that. We may have separate power module for driving separate unit, and all together, all those things are combined together, and we may get a adequate amount of required output. Please set it now. So used in low power, high frequency converters or inverters. Yes, maybe in the later part when we go that we will discuss all those things. Okay, and also maybe the later part after completion of the syllabus, I'll discuss about your current your PV panel, photovoltaic panel, or your solar panel. Some of you might be planning to establish it in your house and other things, because government is trying to give subsidy and other things. Please remember me, okay? So these are all things, the fundamental which we are learning is here only. We are trying to use a power electronics, either a converter or a power electronics inverters. Okay, that's why the lot of current appliances, current applications are related to this only. Even for your robotic modeling, robotic functioning, I think you people are related to robotic specialized people. So maybe many of your applications you are using, I think, DC motors. That means you need a suitable controller or you need a suitable processor to control certain part. So that's why these type of components are much essential when we go for a design of our own power modules or a power drive or a power system unit. Please remember me. So maybe I think today people are speaking about all electric vehicle, right? Many places people are speaking about electric vehicle, and you also looking into that. Daily people are speaking about electric vehicle charging station. What exactly people are speaking? Even you yourself can able to establish a charging station. All this fundamental only which we are discussing earlier. Also you learned. Now we are just here. We are learning about the integration part. These concepts only everywhere people are looking into electric vehicle or electric charging station, all those things. Don't think that it's a new miracle or new invention, nothing. Everything are available. People are introducing new technologies. Please remember me. Charging, okay, I can either I store the charge and I retrieve the charge, one option. Otherwise, I may take the charge from the line, from the solar, from the hydro, from the nuclear, from the other wind and other sea. Also, these all the things are available, or these all the things are existing in the society, right? We all know about how do we generate power, how do we receive power, all those things. Now, due to the utility and due to the demand, due to more people started using on more appliances, more industries, more sophisticated futures, thereby we may have a power shortage or a power demand. In that cases, people are thinking about the alternative energy or the alternative resources or the alternative methods and modules. Got my point? Therefore, now Another one, people are okay. Earlier people are dependent on, people were solely dependent on about diesel, petrol and other things. Now okay, people thought that okay, in order to deviate with the people, okay, we may have a charging station, or we may use the concept called electrovoltaic principle, or electric vehicle principles, or photovoltaic concepts, or the solar panel. These all things are came into existence after the emerging technologies or emerging multidisciplinary area developments happened in the society in terms of mechatronics or microelectronics or optoelectronics, when these things are came into existence. Please remember. That's why I told you mechatronics or mechatronics based robotic specialized people are much wanted in the society on to carry out many multidisciplinary tasks. Otherwise, electrical man will do electrical, mechanical man will do a mechanical part. Who is trying to integrate? Or a computer man will do only computer, or he will do only computer coding, or computer integration, or computer storage and other things, or data analytics, or networking. Who will be a moderator to integrate all those things? Being a multidisciplinary engineer only can able to integrate many multidisciplinary areas on a single phone. Then who will be called as a multidisciplinary person? Mechatronics or a robotic specialized person only will be called as a multidisciplinary engineer. Thereby, you are trying to integrate many things on a single phone. Even medical or industry, automobile industries and other things are now integrated. Even now, people are speaking about all automobile industries, right? All automobile, what are exactly happening? All your sensors and other things only they are using. People earlier they spoke about automobile is a separate sector, something like that. But now, please remember in your mind, all sensor fabrications or all signal acquiring, everything will be based on this type of basic power terminologies. Because when you wanted to analyze the sensing effect, or when you wanted to acquire the amount of signal, that means what concept became that? All these power terminologies are the switching concepts. These switches plays a vital role on the basic control. Please remember. From that only they developed their own ideas, and they are trying to integrate many multidisciplinary things. So please remember in your mind, you people are much essential and much wanted in the society. That's why now we are trying to integrate switches along with the power electronics devices. That's why these devices are called power electronics. Okay, whatever we are discussing, electronic component, and we are trying to integrate with the electrical. That means we are trying to speak about more amount of switching frequency. When I wanted to drive a power drive, then I wanted to maintain about the switching frequency. Switching frequencies are much higher, like 100 kilohertz, 100 megahertz, something like that. We are speaking about in terms of a kilohertz or megahertz or gigahertz. We are speaking. That's why these power modules are came into existence in the name of called as solid state switches. Now here we are trying to integrate this solid state switches along with the device mechanisms, or along with the hardware drivers. So these are all the basic switches we are trying to learn for us to know things. That's why the earlier application maybe might be used for the what I say SMPS, the other, even some more. You might be heard about regulated power supply, switch mode power supply. So even some more power supplies you might be learned. I forgot some of the names. There are n number of things are there. Even the step up, step down. All these concepts, you may step up or the voltage, or you may step down the voltage with the help of a transformer. Then after that, what you will do? You are going to use these switches only. With that help of the switches only, you are trying to use 5 volt or 10 volt requirement, or you wanted to boost up the voltage, or we may call it as buck converter or boost converter. These all things are the origin on the help of this basic switches only. Either a diac, a triac, BJT, UJT, MOSFET, all those things. Okay, so if you, I told you in the today's beginning of the class, if you keep on increasing the components, component will be looks like bulky, more costlier, and also more losses will be there. I may have more switching losses. Maybe the later part I'll tell you what exactly we are trying to speak about in losses. Because our the devices are much oriented in terms of two things. One is in terms of frequency, and another one in terms of time. So here, power MOSFET is a unipolar device, and operation depends on the flow of majority variation. And here, power MOSFET may be derived with the help of a basic origin on your BJT. Please remember in your mind. So this may be the structural representation of your power MOSFET. Maybe you learned in the earlier class. We may have a P channel, N channel. Then you may have a source, drain, and gate. How these source, drain, and gate are connected. Your load is always connected to between what? The source and the drain. Please remember in your mind. And in your source side only, you will have the input supplies. But at the same time, load, I am speaking about output. Please remember in your mind. Load in the sense, I am speaking about the output. Output may be connected across your source and drain. Okay. Maybe the next class, I think now time is running shortage. Okay, maybe the next class will continue with the construction details of the MOSFET and the operations and other things. What are all the characteristics? Because characteristics plays a vital role on our area. Depends on the characteristics and depends on the amount of voltage on the characteristic point of view, either a drain characteristics or the source drain characteristics values. We may decide about that. For which operating condition or which safe operating condition this device may work. Maybe in the later part we will discuss about that. In continuation, we will do it in the next class. Okay, just stop sharing this one. Please be online. I think now the time is. Yeah, just a minute. I'll take the attendance. Please be online. Guys, please turn on your mic and please respond me. If anyone in between disconnected, please remind me. Okay. Number 26. Vice Chancellor. Yeah, 27.
Present, sir.
Sir, 28. Vikesh. Yeah, 29. Dhananjay.
Present.
Number 30. Arya. 30. Srishita Arya. Absent. 31. Sanjay Patil. 32.
Present, sir.
Sri Darshan. 33. Vishnu.
Present, sir.
34 Tarun.
34 present, sir.
35 Jaideep.
Present, sir.
36 Anshul Mehta.
Present, sir.
37 Mugilan.
37 present, sir.
Mugil. 38
38 present, sir.
39 Nitish.
39 present, sir.
40 Manichalman. 41 Mohammed.
Present, sir.
42 Matiswaran. 42 Madheshwaran. Okay, 43 Sudarshan Banerjee.
Present, sir.
44 Jashwant.
Present, sir.
45 Suraj Menon.
Present, sir.
46 Ritesh Babu Alam.
Present, sir.
47 Mark Henry D'Souza.
Present, sir.
48 Shivaguru.
Present, sir.
49 Sylvester Francis.
Present, sir.
50 Bharatwaj. 50 Bharatwaj Srinivas. 51 Jubin Kurian Baiju. 52 Hari Krishnan.
Present, sir.
53 Ashita.
Present, sir.
54
Present, sir.
Banode. Then 55
Present, sir.
Mohammed Naeem.
Yes.
57
Yes, sir.
Subin Babu.
Yes, sir.
58
Present, sir.
59
58 present, sir.
60 Jayshankar.
60 present, sir.
61 Darshan Bharat.
61 present, sir.
62 Ganesh Krishna. 62 any idea? 63 Pawan
Present,
Ganesh.
sir.
64 Joel.
Present, sir.
65 Saritesh Urmila.
Present, sir.
66 Hariharan.
Present, sir.
67 Jiva.
Present, sir.
68 Abhijit Nair. I think Abhijit Nair only informed him. Okay, fine. Then 69 Samuel Pillai.
69 present, sir.
70 Hemant.
Present, sir.
71 Praneeth.
Yes, sir.
72 Raghavendra.
Yes, sir.
73
Jagish present, sir.
Yeah, Jagish. Okay.
Present, sir.
74 Katuri Chandan Sai. 74 Katuri Chandan Sai. 75 75 Ayushman Bhatia. 75
Sir, number 30, sir.
just a minute. 76 Kola Shanmukh Sai.
Present, sir.
77 Alok Ranjan Panda.
Present, sir.
Okay, I'll just read the absentee's name. If anyone is turned up, please respond me. Number 30 Sri Shitari.
Yes, sir.
Yeah. Then 42, Matheswaran. 42, Matheswaran. Absent. Then 50, Bharatwaj. 50, Bharatwaj. Any idea? 51, Jubin, Kuri and Baiju. Jubin?
Sir, so he's present, sir. I don't think his mic is working. He's raising his
Okay,
hand.
okay.
Sir, present,
Okay,
sir.
Yeah, what about 50, Bharatwaj? Then 62, Venish Krishna. 62, Venish Krishna. Then 75, Aishman Bhatia. Okay, guys, in the next class, we'll continue about that. I think you have some 2 or 3 days holiday, right? Please check your Zoho, okay? Check your Zoho and accordingly you plan. Maybe the next day order, we will meet in the afternoon. Okay, thank you. Now you can leave. Thank you.
Thank you, sir.
Yeah, thank you. Muhammad, are you there in the line? Who has recorded today?